In this video, we're going to jump into the often confusing world of quantitative data analysis. We're going to explore what quantitative data analysis is, some of the most popular analysis methods, and how to choose the right methods for your research. We'll also cover some useful tips as well as common pitfalls to avoid when you're undertaking quantitative analysis. So grab a cup of coffee, grab a cup of tea, whatever works for you, and let's jump into it. Hey, welcome to Grad Coach TV, where we demystify and simplify the oftentimes intimidating world of academic research. My name's Emma, and today we're gonna unwrap the topic of quantitative data analysis. If you're new here, be sure to hit that subscribe button for more videos covering all things research related. Also, if you're looking for hands-on help with your research, check out our one-on-one coaching services, where we help you through your dissertation, thesis, or research project step by step. It's basically like having a professor in your pocket whenever you need it. So if that sounds interesting to you, you can learn more and book a free consultation with a friendly coach at www.gradcoach.com. All right, with that out of the way, let's jump into it. Quantitative data analysis is one of those things that often strikes fear into students. It's totally understandable. Quantitative analysis is a complex topic, full of daunting lingo like medians, modes, correlations, and regression. Suddenly, we're all wishing we'd paid a little more attention in math class. Now, the good news is that while quantitative data analysis is a mammoth topic, gaining a working understanding of the basics isn't that hard, even for those of us who avoid numbers and math at all costs. In this video, we'll break quantitative analysis down into simple, bite-sized chunks so you can get comfy with the core concepts and approach your research with confidence. So let's start with the most basic question. What exactly is quantitative data analysis? Despite being quite a mouthful, quantitative data analysis simply means analyzing data that's numbers-based, or data that can be easily converted into numbers without losing any meaning. For example, category-based variables like gender, ethnicity, or native language can all be converted into numbers without losing meaning. For example, English could equal 1, French could equal 2, and so on. This contrasts against qualitative data analysis, where the focus is on words, phrases, and expressions that can't be reduced to numbers. If you're interested in learning about qualitative analysis, we've got a video covering that as well. I'll include a link below. So, the next logical question is, what is quantitative analysis used for? Well, quantitative analysis is generally used for three purposes. First, it's used to measure differences between groups. For example, average height differences between different groups of people. Second, it's used to assess relationships between variables. For example, the relationship between weather temperature and voter turnout. And third, it's used to test hypotheses in a scientifically rigorous way. For example, a hypothesis about the impact of a certain vaccine. Again, this contrasts with qualitative analysis, which can be used to analyze people's perceptions and feelings about an event or situation. In other words, things that can't be reduced to numbers. So, how does quantitative analysis work, you ask? Well, since quantitative data analysis is all about analyzing numbers, it's no surprise that it involves statistics. Statistical analysis methods form the engine that powers quant analysis. These methods can vary from pretty basic calculations, for example, averages and medians, to more sophisticated analyses, for example, correlations and regressions. Sounds like a bunch of gibberish? Don't worry, we will explain all of that in this video. Importantly, you don't need to be a statistician or a math whiz to pull off a good quantitative analysis. We'll break down all the technical mumbo jumbo in this video. So let's start by taking a look at the two main branches of quantitative analysis. As I mentioned, quantitative analysis is powered by statistical analysis methods. There are two main branches of statistical methods that are used: descriptive statistics and inferential statistics. In your research, you might only use descriptive statistics, or you might use a mix of both, depending on what you're trying to figure out. In other words, depending on your research questions, aims, and objectives. I'll explain how to choose your methods later in this video. So, what are descriptive and inferential statistics? Well, before I can explain that, we need to take a quick detour to explain some lingo. To understand the difference between these two branches of statistics, you need to understand two important words. These words are population and sample. First up, population. In statistics, the population is the entire group of people, or animals, or organizations, or whatever, that you're interested in researching. For example, if you were interested in researching Tesla owners in the US, then the population would be all Tesla owners in the United States. However, it's extremely unlikely that you're going to be able to interview or survey every single Tesla owner in the US. Realistically, you'll only get access to a few hundred or maybe a few thousand owners using an online survey. This smaller group of accessible people whose data you actually collect is called your sample. So, to recap, the population is the entire group of people you're interested in, and the sample is the subset of that population that you can actually get access to. In other words, the population is the full chocolate cake, whereas the sample is just a slice of that cake. Can you see what I've got on my mind? Anyhow, why is this sample population thing important? Well, descriptive statistics focuses on describing the sample, while inferential statistics aim to make predictions about the population based on the findings within the sample. In other words, we use one group of statistical methods, descriptive statistics, to investigate the slice of cake, and another group of methods, inferential statistics, to draw conclusions about the entire cake. And there I go with the cake analogy again. But to be fair, I always have chocolate on my mind. So with that out of the way, let's take a closer look at each of these branches in more detail, starting with descriptive statistics. Descriptive statistics serve a simple but critically important role in your research: to describe your data set, hence the name. In other words, they help you understand the details of your sample. Unlike inferential statistics, which we'll get to later, descriptive statistics don't aim to make inferences or predictions about the entire population. They're purely interested in the details of your specific sample. When you're writing up your analysis, descriptive statistics are the first set of stats you'll cover before moving on to inferential statistics. But depending on your research objectives and research questions, they may be the only type of statistics that you use. We'll explore that a little later. So, what kind of statistics are usually covered in this section? Well, some common statistical tests used in this branch include the following. The mean. This is simply the mathematical average of a range of numbers. Nothing too complicated here. Next is the median. This is the midpoint in a range of numbers when the numbers are all arranged in order. If the data set makes up an odd number, then the median is the number right in the middle of the set. If the data set makes up an even number, then the median is the midpoint between the two middle numbers. Next up is the mode. This is simply the most commonly repeated number in the data set. Then we have standard deviation. This metric indicates how dispersed a range of numbers is. In other words, how close all the numbers are to the mean, the average. In cases where most of the numbers are quite close to the average, the standard deviation will be relatively low. Conversely, in cases where the numbers are scattered all over the place, the standard deviation will be relatively high. Lastly, we have skewness. As the name suggests, skewness indicates how symmetrical a range of numbers is. In other words, do they tend to cluster into a smooth bell curve shape in the middle of the graph? This is called a normal or parametric distribution. Or do they lean to the left or right? This is called a non-normal or non-parametric distribution. Okay, are you feeling a bit confused? Let's look at a practical example. On the left-hand side is the data set. This data set details the body weight in kilograms of a sample of 10 people. On the right-hand side, we have the descriptive statistics for this data set. Let's take a look at each of them. First, we can see that the mean weight is 72.4 kilograms. In other words, the average weight across the sample is 72.4 kilograms. Pretty straightforward. Next, we can see that the median is very similar to the mean, the average. This suggests that this data set has a reasonably symmetrical distribution. In other words, a relatively smooth, centered distribution of weights, clustered towards the center. Moving on to the mode. Well, there is no mode in this data set. This is because each number presents itself only once, and so there cannot be a most common number. If, hypothetically, there were two people who were both 65 kilograms, then the mode would be 65. Next up is the standard deviation. 10.6 indicates that there's quite a wide spread of numbers. We can see this quite easily by just looking at the numbers, which range from 55 to 90. This is quite a stretch from the mean of 72.4, so we would expect the standard deviation to be well above 0. And lastly, let's look at the skewness. A result of negative 0.2 tells us that the data is very slightly negatively skewed. In other words, it has a very slight lean. This makes sense since the mean and the median are only slightly different. As you can see, these descriptive statistics give us some useful insight into the data set. Of course, this is a very small data set, only 10 records, so we can't read into these statistics too much. But hopefully, this example helps you understand how these statistics play out in reality. Also, keep in mind that this is not a list of all possible descriptive statistics, just the most common ones. So at this point, you might be wondering, but why do these matter? Well, while these descriptive statistics are all fairly basic, they're important for a few reasons. Firstly, they help you get both a macro and micro level view of your data. They help you understand both the big picture and the finer details. Secondly, they help you spot potential errors in the data. For example, if an average is way higher than you'd expect, or responses to a question are highly varied, this can act as a warning sign that you need to double check the data. And lastly, these descriptive statistics help inform which inferential statistical methods you can use, as those methods depend on the shape of the data. We'll explore this a little bit more later on. Simply put, descriptive statistics are really important, even though the statistical methods used are pretty basic. All too often at Grad Coach, we see students rushing past the descriptives in their eagerness to get to the more exciting inferential methods and then landing up with some very flawed results. Don't be a sucker. Give your descriptive statistics all the love and attention they deserve. All right, now that we've looked at descriptive stats, let's move on to the second branch of quantitative analysis, inferential statistics. As I mentioned, while descriptive statistics are all about the details of your specific data set, your sample, inferential statistics aim to make inferences about the population. In other words, you'll use inferential statistics to make predictions about what you'd expect to find in the full population. What kind of predictions, you ask? Well, generally speaking, there are two common types of predictions that research try to make using inferential stats. Firstly, predictions about differences between groups. For example, height differences between children grouped by their favorite sport. And secondly, relationships between variables. For example, the relationship between body weight and the number of hours a week a person does yoga. In other words, inferential statistics, when done correctly, allow you to connect the dots and make predictions about what you'd expect to see in the real-world population based on what you observe in your sample data. For this reason, inferential statistics are used for hypothesis testing. In other words, to test hypotheses that predict changes or differences. Of course, when you're working with inferential statistics, the composition of your sample is really important. In other words, if your sample doesn't accurately represent the population you're researching, then your findings won't necessarily be very useful. For example, if your population of interest is a mix of 50% male and 50% female, but your sample is 80% male, you can't make inferences about the population based on your sample since it's not representative. This area of statistics is called sampling, but we won't go down that rabbit hole here. It's a deep one. We'll save that for another video. So what kind of statistics are usually covered in this section? Well, there are many different statistical analysis methods within the inferential branch, and it would be impossible for us to discuss them all here. So we'll just take a look at some of the most common inferential statistical methods so that you have a solid starting point. First up are t-tests. T-tests compare the means, the averages, of two groups of data to assess whether they are different to a statistically significant extent. In other words, to see whether they have significantly different means, standard deviations, and skewness. For example, you might want to compare the mean blood pressure between two groups of people, one that has taken a new medication and one that hasn't, to assess whether they are significantly different. Simply looking at the two means is not enough to draw a conclusion. You need to assess whether the differences are statistically significant, and that's what t-tests allow you to do. Right, next up is ANOVA. ANOVA stands for Analysis of Variance. This test is similar to a t-test in that it compares the means of various groups, but ANOVA allows you to analyze multiple groups, not just two. So it's basically a t-test, but on steroids. Next, we have correlation analysis. This type of analysis assesses the relationship between two variables. In other words, if one variable increases, does the other variable also increase, decrease, or stay the same? For example, if the average temperature goes up, do average ice cream sales increase too? We'd expect some sort of relationship between these two variables intuitively, but correlation analysis allows us to measure that relationship scientifically. Lastly, we have regression analysis. Regression analysis is similar to correlation in that it assesses the relationship between variables, but it goes a step further to understand the cause and effect between variables, not just whether they move together. In other words, does the one variable actually cause the other one to move, or do they just happen to move together naturally thanks to another force? Just because two variables correlate doesn't necessarily mean that one causes the other. To make this all a little more tangible, let's take a look at an example of correlation in action. Here's a scatter plot demonstrating the correlation, or the relationship, between weight and height. Intuitively, we'd expect there to be some sort of relationship between these two variables, which is what we see in this scatter plot. In other words, the results tend to cluster together in a diagonal line, from bottom left to top right. The more tightly the results cluster together to form a line in any direction, the more correlated they are, and therefore, the stronger the relationship between the variables. As I mentioned, these are just a handful of inferential methods. There are many more. Importantly, each statistical method has its own assumptions and limitations. For example, some methods only work with normally distributed or parametric data, while other methods are designed specifically for data that are not normally distributed. And that's exactly why descriptive statistics are so important. They're the first step to knowing which inferential methods you can and can't use. Of course, this all begs the question, how do I choose the right quantitative analysis methods for my research? Well, that's exactly what we'll look at next. Now that we've looked at some of the most common statistical methods used within quantitative analysis, let's look at how you go about choosing the right tool for the job. To choose the right statistical methods for your research, you need to think about two important factors. One, the type of quantitative data you have, specifically level of measurement and the shape of the data. And two, your research questions and hypotheses. Let's take a closer look at each of these. The first thing you need to consider is the type of data you've collected, or the data you will collect. By data types, I'm referring to the 4 levels of measurement, namely nominal, ordinal, interval, and ratio. If you're not familiar with this lingo, you should hit the pause button real quick and go check out our post over on the Grad Coach blog that explains each of these levels of measurement. I'll include the link below. Okay, so why does this matter? Well, because different statistical methods require different types of data. This is one of the assumptions I mentioned earlier. Every method has its assumptions regarding the type of data. For example, some methods work with categorical data, like yes or no type questions, while others work with numerical data, like age, weight, or income. If you try to use a statistical method that doesn't support the data type you have, your results will be largely meaningless. So make sure you have a clear understanding of what types of data you've collected or will collect. Once you have this, you can then check which statistical methods support your data types. I'll include a link below the video that explains which methods support which data types. Now, if you haven't collected your data yet, you can, of course, reverse engineer the process and look at which statistical methods would give you the most useful insights, and then design your data collection strategy around this to ensure that you collect the correct data types. Another important factor to consider is the shape of your data. Specifically, does it have a normal distribution? In other words, is it a bell-shaped curve centered in the middle? Or is it very skewed to the left or right? Again, different statistical methods work for different shapes of data. Some are designed for symmetrical data, while others are designed for skewed data. This is another reminder of why descriptive statistics are so important, since they tell you all about the shape of your data. The next thing you need to consider is your specific research questions, as well as your hypotheses, if you have some. The nature of your research questions and research hypotheses will heavily influence which statistical methods you should use. If you're just interested in understanding the attributes of your sample as opposed to the entire population, then descriptive statistics might be all you need. For example, if you just want to assess the means or averages and the medians or center points of variables in a group of people, descriptives will do the trick. On the other hand, if you aim to understand differences between groups or relationships between variables and to infer or predict outcomes in the population, then you'll likely need both descriptive statistics and inferential statistics. So it's really important to get very clear about your research aims and research questions, as well as your hypotheses, before you start looking at which statistical methods to use. Never shoehorn a specific method into your research just because you like it or have experience with it. Your choice of methods must align with all the factors we've covered here. All right, now that we've looked at what quantitative analysis is, the two main branches of statistics, and how to choose the right methods for your research, let's recap and bring it all together. We've covered a lot in this video. Well done on making it this far. Let's recap on the key points we've looked at. First, we asked the question, what is quantitative data analysis? As we discussed, quantitative analysis is all about analyzing number-based data, which can include both categorical and numerical data. These data are analyzed using statistical methods. The two main branches of statistics are descriptive statistics and inferential statistics. Descriptives describe your sample, the slice of the cake, while inferentials make predictions about what you'll find in the population, the full cake, based on what you've observed in the sample. As we saw, common descriptive statistical metrics include the mean, the median, the mode, standard deviation, and skewness. On the inferential side, we looked at t-tests, ANOVAs, correlation analysis, and regression analysis, all of which can help you make predictions about the population. Lastly, we asked the important question, how do I choose the right statistical methods? As we discussed, to choose the right statistical methods, you need to consider the type of data you're working, as well as your research questions and hypotheses. Remember, in this video, we've only looked at a handful of the most common quantitative methods. There are many, many more. So be sure to check out the Grad Coach blog, as well as the other links below this video to get a fuller picture of what all's on offer in terms of statistical methods. Also, if you'd like us to cover any of the methods in more detail, be sure to leave a comment below. All right, that wraps it up for today. If you enjoyed the video, hit that like button and leave a comment if you have any questions. Also, be sure to subscribe to the Grad Coach channel for more research-related content. Lastly, if you need a helping hand with your research, check out our private coaching service, where we work with you on a one-on-one basis, chapter by chapter, to help you craft a winning dissertation, thesis, or research project. If that sounds interesting to you, book a free consultation with a friendly coach at www.gradcoach.com. As always, I'll include a link below. And that's all for this episode of Grad Coach TV. Until next time, good luck.